Welcome back, students. Section 4.3 today, binomial distribution. Go ahead and share my screen. Okay, there we go. Okay. Binomial distribution. Okay, this is a discrete distribution. That's the first thing we need to know, is that this is discrete. Okay, so later on we're going to talk about a continuous function, but this one particularly is discrete. It is oftentimes symmetric, which means that it looks like this, but it is discrete. Okay, often symmetric and discrete. Okay, discrete, symmetric. Okay, so what is the binomial distribution? Suppose we have a procedure that has only two possible outcomes. Usually we refer to them as a success or a failure, right? So we often are interested in repeating the procedure and counting the number of successes we observe. Okay, flipping a coin 100 times and counting how many times it lands on heads results in a binomial distribution. Flip the coin, is it heads? That's a success. Tails, that's a failure. Procedure of flipping a coin, and every time we flip it, we call it a trial. Okay, so the first flip is the first trial, second flip is the second trial, third flip is the third trial. Okay, the binomial is binary. We can separate outcomes into binary events, success or failure. Okay, how do I define a success failure? You know, so is heads going to be a success, or is tails going to be a success? So we have to define which is the success and which is the failure. Okay, do I have independent and identical events? Okay, each trial is independent of each other. Okay, the one trial does not affect the other. Okay, rolling a die, flipping a coin, they're all independent. Okay, and then the number of trials is fixed. Okay, meaning that we don't go on forever. There's a set number of trials. There's a set number of events that happens. You need to ask yourself, how many trials are there? We often use binomial distribution when we have a sample without replacement. Okay, but these do not satisfy independence, right? When we pull a card from a deck and we pull that out, then that's without replacement. Okay, and that can affect, you know, our distribution, our probabilities. Okay, however, if the sample size is less than 5% of the population, meaning that if we have a big population, okay, very large population, then we can basically approximate this to an independent trial. Okay, we can say that it's approximately independent, and each of them, you know, the change from going to without replacement to with replacement is negligible. Okay, so in short, if n over the population size, that n is the sample size, remember that, sample size. Okay, if the sample size over the population is less than 5%, then we can assume each trial is independent. Okay, binomial notation. Okay, S is equal to success, F is equal to failure. The probability of S we call little p. Okay, probability of a success is little p. The probability of a failure is 1 minus p, and that's q. Okay, so for example, if I said that p was 0.25, okay, probability of getting a 1 on a spinner. Okay, so let's look at a spinner here, and we have 1, 2, 3, and 4. probability of getting a 1 on a spinner with 4 areas would be 0.25. So the probability of the success there is going to be 0.25. Okay, what would be the probability of failing or probability of not getting a 1? Okay, that would be 1 minus 0.25 or 0.75 would be what's left over basically. Okay, so getting a 1, 0.25, not getting a 1, 0.75. N is the number of trials. Okay, X is the number of successes. Okay, so if we wanted a certain number of successes out of the trials, okay, and P of X is the probability of getting X number of successes. Okay. Okay, example 1. A trainer is teaching a dolphin to do tricks. The probability that the dolphin successfully performs a trick is 35%. That's a success. That's going to be P. So little p is 0.35. Okay, the probability that the dolphin does not perform the success, that's going to be a failure, is Q, 1 minus P, or 0.65, 65%. Out of 20 attempts, okay, 20 attempts, that's the number of trials. Okay, so out of 20 attempts, the trials is equal to 20. You want to find the probability that the dolphin succeeds 12 times. Okay, so 12 successes. Okay, 12 successes out of 20 trials. Okay, does this sound like a binomial situation? Check the conditions for binomial distribution. Okay, so yes. Okay, do we have successes and failures? Failures. Check. Do we have, what's the other two? Independence? Yes. Are there a number of trials? Yes. So is there success failure? Yep. Is it binary? Yep. Okay. Do we have independence? Yeah, the I is independence. Okay, does one trial influence the other? No. And do we have trials? Yes, we have 20 of them. Okay, find the values of N, X, P, and Q. Okay, well, we already found P and Q. Now you just need to know N and X. Okay, so N is the number of trials. So N is the 20, so 20 attempts. Okay, and X is the number of successes, and that's 12. Okay, and we'll bring P and Q down here as well. P and Q, 0.35 and 0.65. Okay, you flip a coin. And count the number of heads until it lands on tails. Is this a binomial situation? Okay, check to see if the conditions for binomial distribution. Okay, so is it binary? Okay, so we're looking for heads, right? So is it binary? Yeah, we have successes, which would be heads, and we have failures, which would be tails. Okay, are they independent? Are the flips independent of each other? This is a situation where we have independence. Yeah, this is a situation where I can actually write legibly. No, independence. Okay, so do we have independence? Yes. Okay, so that checks. Okay, what about trials? Do we have a number of trials? A set number of trials. And this is no, we do not have a set number of trials. It says just flip it forever until it lands on heads or until it lands on tails. Flip, flip, flip. We don't know. There is no set number of trials. So we can't use the binary here. It's not a I'm sorry, we can't use the binomial. No set number of trials, so that fails. Okay, binomial formula, okay, is the probability of X successes out of N trials. We multiply the following, okay? We have N choose X. This is N choose X. Okay, out of N, choose X. And again, there's a formula for this, N choose X. Okay, you don't really need to know the formula because we're going to get the value for this on the calculator or on StatCrunch. But the formula is if I have what's called N factorial here over N minus X factorial X factorial. And factorial is just, if I have 3 factorial, that's 3 times 2 times 1. Okay, if I have 5 factorial, that's 5 times 4 times 3 times 2 times 1. So you kind of see the pattern there. Okay, so we have this formula. Again, you don't need to know the formula. That's more for math class, not so much a statistics class. We're just going to use the N choose NCX, okay, on the calculator. Okay, so on the calculator, I'll just say this real quick, calculator. Okay, it's N choose X. Out of N choose X items. That's what this guy is, NX. Okay, is N choose X. On StatCrunch, it's a little different. StatCrunch. On StatCrunch, it's combination. It's combination N choose X. And I'll show you how to get that in a little bit. Okay, it's the combination of N choose X. Maybe I get rid of these little things here. Okay, but that's how we do it in StatCrunch. Okay, so let's see how we get these values here. Okay. Okay, number of ways to choose X successes out of N trials, probability of successes X times, okay, and the probability of failures, the remaining trials. This is Q to the N minus X, that's the remaining ones. So 3 pieces there for the probability of X. So let's do an example here to try to make sense of this formula here. Okay, I'll highlight that real quick. Let's move that down. Let's go to my highlighter and just highlight this bad boy there. Okay, so how do we get that in our calculator or in StatCrunch? Okay, so I'll show you how we use the formula, and then I'm just going to show you that we don't even need the formula. Honestly, we can just use the calculator or StatCrunch and it will do it for us. Okay, do it all for us. We don't want to be lazy. We should know at least how to use the formula. So let's look at an example here. When an adult is randomly selected, there is 0.85% probability that a person has a Facebook account. Suppose 5 adults are selected at random. Okay, so there's our P. Okay, P is equal to 0.85 there. Okay, that's our P. Might be hard to see, but that's our P is equal to 0.85. Okay, I'll just put 0.85 here. Okay, maybe I'll zoom in. Okay, so P is equal to 0.85. What is the probability that exactly 3 out of the 5 selected have a Facebook account? Okay, so let's look at the formula here. Probability X is equal to N choose X, P to the X times Q, N minus X. Okay, so N choose X, that's N is the number, is the total number of trials or people selected here, and that's 5, N is 5. And we want to know exactly 3, so this is going to be out of 5, choose 3. P to the third, well, what's P? P is 0.85 to the third times Q, but what's Q? Q is how I get to 1, right? If I add 0.85, how much am I going to take to get to 1? Or what's 1 minus 0.85? Okay, and then the q's are what's left over. These will always add up. Okay, these exponents will always add up to our n. Okay, so notice that 3 plus 2 is equal to 5. Okay, they're always going to be add up to n. Okay, the number of trials. Okay, so 1 minus 0.85, that's 0.15. So this is going to be out of 5, choose 3. Okay, times 0.85 to the third power times 0.15 to the second power. Okay, so now we need to figure out how to get this 5 choose 3 guy here. Okay, so how do we get this 5 choose 3 thing? And we can use the calculator to get us that. So let's go to the calculator here, and we're going to go to math, the math key. Okay, we have the math key, and then we're going to go over to probability. And see this NCR here, this N choose R, that's 3. I'm going to go down to 3 here, and I'm going to hit enter. And that's going to give me out of N choose R items, or in this R case, it's X. Out of N choose X. And so this is out of 5, choose 3. We go, oh, okay, well, that's 10. Oh, that's nice. Okay, so out of 5, choose 3. That's how you get this on the calculator. Now, how would we do this on StatCrunch? Well, I'm glad you asked. Let me show you here. So what we're going to do here is I'm going to go to this guy here, and I'm going to go to data. Okay, I'm going to go to data, and I'm going to go to compute. Oops, data, and then compute, and then expression. Okay, so it's saying, what expression do you want to compute on here? I'm going to say, well, I would like to compute shift parentheses. Okay, do I need parentheses? Maybe not. Okay, let's do combination. Okay, now I need parentheses, shift parentheses, combination. What's the combination for n comma x? So we want 5 comma 3, right? 5 comma 3. Okay, so shift and then close the parentheses. I'm gonna click build. Oops, I don't want build. I want to click compute. Compute, and it tells me, oh, your combination for 5 choose 3 is 10. That's nice. Okay, so StatCrunch, you can do the same thing. You just again go to data, and then compute, and then expression, and it's this combination. Okay, 5 choose 3. Okay, and we're good. Okay, so that's how you do it on StatCrunch. Okay, let's go back to the calculator real quick, because, well, let's go back here, because we want to compute this whole thing. Well, what was 5 choose 3? We saw that was 10 times 0.85 to the third power times 0.15 to the second power. And I want to calculate this. Let's go to our calculator. Okay. And I'm going to say, okay, well, this is going to be 10 times 0.85 raised to the third, that's my successes, times 0.15 raised to the second. Okay. And I'm getting 0.138, I'll call that 2, 0.1382. So that's a probability of out of 5 people, 3 have a Facebook account. Okay, so let's write that up. Okay, so this is going to be 0.1382, or 13.8% probability that out of 5 people, 3 have a Facebook account. Okay, not too high. You know, it is what it is. So yeah. So, but that's out. That's exactly out of 5. Exactly 3. Okay, that's exactly 3. Have a Facebook account. Right. So what are the other choices? Well, they could be 0, 1, 2, 4, or 5. So there's a lot of other possibilities here. Okay, 0, 1, 2, 4, or 5. Okay, so this is just the probability that exactly 3 of them happen. Okay, 13.8%. Okay, so what's the probability? Okay, that that 3 or 4 adults have an account. Okay, so probability that x is equal to 3, we already saw that. Okay, probability that x is equal to 3 was 0.1382. That was from part A. Now we just need to figure out, well, what's the probability x equals 4? Okay, and then add those two together. Okay, so we need to go through this whole process again. Okay, so this is going to be out of 5, choose 4 times 0.83 to the 4th power times 0.15 to the, I'll go 5 minus 4. But eventually you're going to see if this is a 4 and they're supposed to add up to 5, then this has got to be a 1, right? Okay, so I'll write this as 5 choose 4, 0.8, this should be a 5, right? 0.85 to the 4th power times 0.15 to the 1st power, which is just 0.15. So I can plug that into my calculator all at once. Okay, so I would go math. Let me clear this real quick. Okay, I'm going to go math. And then, the math key again. So it shows up math and then go over to probability and NCR. Okay, so what do we want? We want out of 5, choose 4. And then I can just continue on and go times 0.85 raised to the 4th power times 0.15 raised to the 1st power, but anything raised to the 1st is just itself. So then I can just hit enter. I'm like, oh, well, that's 0.3915. 0.3915. That's exactly 4 of them. Okay, that's kind of cool. So 0.3915. Okay, so this is 0.3915. And so what if I want the probability of 3 or 4? So the probability of 3 or 4, then I'm just going to add these two numbers together. The probability of 3 plus the probability of 4. Okay, well, I already have the probability of 4 in my calculator. Wrong calculator. Okay, and so I'm just going to say, I'm just going to hit the plus sign, and it's going to pull that previous answer, and it's going to add now the one before it, which I can either arrow up and grab it, or I can just go 0.13817815. There we go. And it's 0.5297. Okay, 0.5297. Okay, so that's 3 or 4. So let me grab that guy here. 0.52, what did I say? 97. Sorry. Yeah, 97. 0.5297. That's probability of 3 or 4. Okay, what is the probability that more than 3 adults have an account? Well, probability more than 3 adults, x is greater than 3, okay, is the probability that x is equal to 4 or 5. Okay, so I would have to figure out what is the probability of 5. Okay, so again, this is going to be 5 choose 5. This is 5 successes times 0.85 to the 5th times 0.15 to the 0. Okay, again, they both have to, the exponents have to add up to the n. So if there's 5 successes for here, then there's 0 failures, 5 successes, 0 failures. Okay, so then this becomes, okay, out of 5, choose 5. Well, how many ways can I choose 5 out of 5? Well, there's only one way. Okay, and you'll see that, we can see that on the calculator too. If I go to again, math, and I go over to probability, I go down to 3. Okay, and if I do 5, choose 5, again, if I hit enter, you'll see it is equal to 1. Okay, because there's only one way to choose 5 items out of 5. You just grab them all, you choose them all. Okay, so out of 5, choose 5. Okay, and then so this is just going to be 1 times 0.85 raised to the 5th power times 0.15 raised to the 0 power. But what's anything raised to the 0 power? Well, anything raised to the 0 power is just 0. I mean, it's not 0. What am I saying? It's just 1. Okay, it's just 1. And so I get this thing to be just 0.85 to the 5th power. Okay, and to prove that it's just 1, I'll go 0.85 raised to the 5th power on itself, and you'll see I get the same result. Okay, so 1 was 1, and 0.15 was also 1. 0.15 to the 0 is also 1. So I get the same result here. So it's 0.4437. So this is 0.4437, but that's only the probability that x is equal to 5. Okay, I want the probability of x is equal to 4 or 5. And so what am I going to do? I'm going to add these two numbers together. So 0.3915, so plus 0.3915. Okay, and I get 0.8352. Okay, 0.8352. So probability of 4 or 5 is 0.8932. I'm going to box that. Okay, my work is below. Okay. And this guy I'm going to box as well. Okay, so this is my answer. Okay. Okay, let's continue on. Binomial probabilities on the calculator. Now, the calculator will actually do the binomial probabilities for us. Okay, and we'll calculate the binomial probabilities for us. We don't have to calculate them by hand, like what we just did there. Okay, it will actually do it for us. So, how do we do this on the calculator? Well, we go to second data, okay, distribution, and then 4 is the binomial PDF. Okay, so second data, which is the VARS key, I believe. And then we go to distribution binomial PDF. Okay, that's if x is equal to x. However, if x is less than or equal to x, say we want everything from 0 up to a number. Okay, from 0 up to a number, that's binomial CDF. Okay, so it depends on what we're asking, what they're asking for. Okay, so if it's less than a number, okay, say that we want all the probabilities up to a certain value, then that's the cumulative function. Okay, if we just have equals, that's the probability function. Okay, so let's let's do our previous example. Let's just do the 5 choose 3 from before. Okay, remember that 5 choose 3, and then it was 0.85 to the third, and then 0.15 to the second, right? So let's have the calculator do this for us. Okay, so let's clear it. Okay, and we're going to go to second, and it should be VARS here. Second VARS, I believe. Yeah, and it's distribution. It's not data. It's second VARS. That's what I thought it was. Okay, VAR stands for variables, but that's the distribution. Second VARS is distribution. I need to change that in my notes. Okay, it's not second data. It's second VARS. VARS. I'll make sure to change that next time. Okay, second bars, and then I go all the way down, okay, to binomial PDF. Okay, if I want exactly three, then I use the PDF here. Okay, PDF, and I hit enter, and it says, how many trials do I have? And I have, that's what n is. N is the trials. That's 5. Okay, what's the p-value? What's the probability of excuse me, what's the probability of a success? And that was our 0.85. And what's the x value? The x values are the numbers of successes. That's 3. And so all I do is paste that. Now, if you have an older calculator, you'll have to write this completely out. Okay. And you'll just use the commas and the parentheses. Okay, but it'll be binomial PDF, right? And we'll hit enter, and we get that 0.1382 that we got before. Okay. Okay. On StatCrunch, it's actually super easy. This here it's a lot easier on StatCrunch. Let's go to StatCrunch here. Okay, let me clear this. Oops. Let's delete this here. Okay, and what we do is we go to stat and then calculate. Calculators, and it should be a binomial one here. Yeah, binomial. Okay, calculators, and it says, okay, n, what do you want n to be? And I want n to be 5. Okay, and what's the probability of success? That's 0.85. 0.85. And what do you want here? I want n to be, x to be equal to 3. So I'm gonna hit that symbol, and then I go equals 3. So I need to arrow over. Get back my keyboard, please. Okay, arrow over to 3. And I'm going to hit compute. Oh, okay, why do they not like that? Oh, there's 2 decimals. That's why. Okay, compute. Boom. And we get, again, our 0.138. Okay, and it actually shows me the distribution, which is kind of nice. So for 1, it was very small, 2, and then 3, and then 4, and then 5. Okay, so, 1, 2, 3, 4, 5. These are the distributions. And if I wanted to say, well, what is it for 4? I could easily just go back to 4, hit compute, and it shows me how tall it is for that second line here. Okay. If I wanted both 4 and 5, which was our last one, right? 4 and 5, that means I would want everything greater than 3. Or everything greater than or equal to 4. Okay, so if I said I want everything greater than 3, maybe greater than or equal to be less confusing. If I want everything greater than or equal to 3, okay, it shows already. I don't even have to click compute. It computed it for me already, and it goes 0.8352, which is exactly what we got. Okay, on the previous letter C. Okay, it calculates the 4 and the 5 for me. Okay, it's kind of cool. If I wanted to say, greater than 3, because these are discrete, you have to put in discrete values. 1, 2, 3, 4. Okay, if it's greater than, say greater than 4 here. Okay, that's the last one. That would be 5. If it's greater than 3, that includes 4 and 5. It's the same thing. Okay, so it depends on that what the inequality is telling you. Okay. Okay. If I wanted to get 4 or 5 on the 4 and 5 on the calculator, it's a little different. Okay, I could calculate 4, and then I could calculate 5, or I can use that CDF function. It's a little more confusing to use the CDF function. But it is doable. Okay, so if I go on the calculator and I do the CDF, remember the CDF is everything up to and including, right? So if I wanted everything up to and including 1, 2, 3, that would give me all the values up to 3, but I don't want that. I want 4 and 5, right? So I would do the complement of that. I would do 1 minus the cumulative, right? So let me show you how that works. It's a little confusing, just me explaining it. But if I go to second vars again, and it's distribution, I'm going to arrow up to get it to A. I could just choose, here I'm going to choose B, the binomial CDF. Okay, binomial CDF, because that's everything from 0 up to a number. It's cumulative. Okay, so I'm going to say, oh, okay, I want the binomial CDF here. What's the number of trials? 5. What's my P? P is 0.85. What's my X value? Well, I'm going to do everything up to and including. See that the calculator does everything up to and including. It's a less than or equal to sign. Okay, less than or equal to. Everything up to and including 3. And I'm going to say, okay, paste that. And that gives me this 0.16447. However, I don't want that. I want 4 and 5. This is everything that I don't want. So if I do 1 minus that answer, I can hit second, the negative sign to get an answer, to get the previous answer. Then that gives me my 0.8552 again. Okay, so it's a little more confusing on the calculator, and I'm sorry for that. There's no other way that I can make it, easier. The calculator is just limited. It only gives you, if you were to look at a graph, okay, for the calculator, that's what this whole thing is talking about. If you were to look at a graph for the calculator, it only is going to give you, okay, everything and including up to that value. This would be, the CDF for X is less than or equal to 3. It would give you the 1, the 2, and the 3, and that's it. It just gives you. So if you want the 4 and the 5, you'd have to do 1 minus that. Okay. When adult, here, let's do one with the calculator, and then we'll do one with StatCrunch. Okay. So this will be on the TI calculator. Okay, when an adult is randomly selected, there is 0.85 probability that a person has a Facebook account. We select 50 random adults this time. Okay. What's the probability that exactly 42 have a Facebook account? So out of 50, choose 42. That's going to be times 0.85 to the 42nd times 0.15 to the 8th, because 42 and 8 add up to 50. Okay. Okay. So this is going to be equals. This is going to be, what's the probability that X equals 42? And I'm going to let the calculator do that for me this time. Okay, just let's go to the calculator. So this is a binomial PDF. PDF is because it's equals. It's equals to a number. Okay, so I'm going to go to second vars again. I'm going to arrow up and go all the way to A this time, and that's binomial PDF. And this is how many trials do you have? Well, I have 50 trials this time. What's your P value? What's your probability? 0.85. How many successes did you have? 42. It's like, okay, go ahead and paste that. And I get 0.1493. 0.1493. Okay, so this is 0.1493. What's the probability that no more than 42 adults have a Facebook account? No more. So I want, this is going to be the probability that X is less than or equal to, we're going to use the less than or equal to because we're using the calculator, less than or equal to no more than 42. So no more than 42 means what? No more than, we stop at 42 and we can't have anything more. So this is less than or equal to 42, which is going to be the binomial CDF. We're going to use binomial CDF here. Before we used binomial PDF. Okay, again, much more confusing on the calculator, and I'm sorry, there's nothing to do about that. This is what it is. Okay, for the calculator. Okay, if it were me, I would use StatCrunch for the binomials because it's less confusing. But if you only have one, device to use, then just use what you have. Okay, so Probability x is less than or equal to 42. Let's plug that in. Okay, it's basically the same thing we did before. It's just instead of the binomial PDF, it's the binomial CDF. Let me clear this. And we're going to go second vars, and we're going to go up to B this time, the binomial CDF. We're going to go, okay, how many trials were there? 50. What's the probability? 85%. And let's do the X value, which is 42. Okay, and we're going to paste that and hit enter. And now we get 0.4812 binomial CDF. Okay, 0.4812. Okay. So go back. It says 0.4812. Okay. What is the probability that at least 42 adults have a Facebook account? At least 42 adults have a Facebook account. Well, let's think about what that means. Probability that at least 42 adults means that we have X is less than or equal to 42. Okay. So, but we want a less than or equal to symbol here. So we have to think about this, right? In terms of, well, that's going to be 1 minus, that's the complement of everything below 42. Well, what's everything below 42? Well, that's 0 to 41. So this is the probability of X is less than or equal to 41. Okay. So we just have to calculate the probability X is less than or equal to 41. Why do I have to do that? Change it to the less than or equal to, because we're on the calculator. Okay, because CDF is only less than or equal to. And why is this not 41 and not 42? Why did we not go less than or equal to 42? Because we don't want to include 42. So we go one less, and that's going to be the next discrete value. So it's one less, which is 41. Remember, they come in whole items, right? So there's no 40.5 or 40.75. There's just, or 41.25. It's 42 and then 41. Well, what's less than 42? 41. We want everything up and including 41. Okay, don't go to 42 or you'll make a mistake. So this is 1 minus probability X is less than or equal to 41. Go to the calculator. Okay, so I can do this all at once, but maybe I don't want to. I'm going to go to second vars. Okay, distribution. What's the PDF that CDF that we're working with? It's 1 to 41, right? So I'm going to go all the way up to 41 here. Just change my X value, 41. And I'm going to get that value. Now, this is everything that I don't want. I don't want all the stuff 0 to 41. So what do I want? I want the complement of this. I want 1 minus this previous answer. Now, I could either go up here and steal it and just copy and paste it, or I could go and hit the answer key, which is the second negative sign. Okay, delete this. I'm going to go second negative sign for the answer. That'll plug in the previous answer, and it gives me 0.6681, which is what I want. Okay, that's the complement. So this is equal to 0.6681. Okay. So probability. Okay, let's do the next one, but it's going to be a whole lot easier because we're going to use StatCrunch. Okay, let's do this one that involves StatCrunch. Okay, you're guessing a multiple choice test. Okay, so when you guess, what does that mean? It means that you have a guess on a multiple choice test. Okay, there are 20 questions on the test, each with 4 multiple choice options. Okay, so what's the probability of getting something right? Well, if you just guess, it's going to be 1 out of 4, right? So P is equal to 1 out of 4, which is 0.25. Okay, so what would that make Q? Q would be 1 minus 0.25, which is 0.75. Okay. You are hoping for at least 70%, which is 14 questions out of 20. Okay. What is the probability that you get exactly 70% on the test, or exactly 14 out of 20? So again, that's going to be 20 choose 14, right? Times 0.25 to the 14th power times 0.75 to the 6th power, because again, 14 and 6 have to add up to 20. So again, I could use the NCR, okay, or the combination, or I could just do this on StatCrunch. It's a whole lot easier to do it on StatCrunch. So we could use the calculator, calculate this all out, and do the PDF. This would be a PDF, or we can just use the StatCrunch. So let's do that. So this is going to be probability x equals 14, right? So what's the probability that x is equal to 14 here? Okay. So I already have this up, but let me show you, let me remind you where to get it. Okay, you go to stat calculators, and then binomial. Okay, stat calculators, binomial. Okay, so we want n to be equal to 20. That's the number of items on the test. Okay, and what's the probability of getting one right? That's 0.25. And what do we want? We want exactly, equal sign, exactly, not 5, we want exactly 14. Okay, so let's compute that, 14, and compute. Okay, so exactly 14 is a small number. This is the probability that you would pass guessing, is 0.000257. It's less than 1% chance of guessing and getting a passing grade. This is why we don't want to guess, unless we're incredibly desperate on an exam. Okay, so let's write this number down. How many zeros are there? There's 1, 2, 3, 4 past the decimal place. So this is 0.000257. Yeah, pretty small number. Okay. What's the probability of not just getting a 14? But what's the probability of this is getting a 70% probability of getting a 70%. What's the probability of just passing the test? 70% or better. Okay, so the probability of getting X is greater than or equal to 14. Okay, well, let's just change the symbol in StatCrunch. It's that easy. Just change, oops, let's go back to StatCrunch. Change the symbol in StatCrunch. Probability X is greater than or equal to, okay, and it computes it. Okay, boom, 0.0123, still 4 zeros, I think. Yep, still 4 zeros, 0.2951. It went up a tiny bit, but it's still incredibly low. Okay, so this is 0.00002951, still incredibly low. Okay, this is your this is your chance of guessing on the exam and passing. Okay, so let's multiply this thing by 100. So it's a 0.002951% chance. Yeah, basically, okay, very low chance of passing. Okay, let's talk about our mean and standard deviation real quick, and for the binomial. What's the mean and standard deviation? Okay, the mean is the expected value is n times p. It's the number of trials times the probability. The variance is NPQ, and the standard deviation is just the square root of NPQ. Okay. Okay, so let's do an example here. You flip a coin 200 times. Okay, if X is a random variable that counts the number of times it lands on heads, okay, then X is the binomial distribution with n equals 200 and P is 0.05. What is the expected value of X? Okay, so E of X is equal to n times P. What's the expected number of heads if you flip the coin 200 times? Well, you should know that. What is the expected number of heads? Well, it should be half the time, right? That's the expected number. If I flip it 200 times, then what's half of 200? Well, it's 100. So does this make sense? Well, what's n? N is 200. What's P? P is 0.5. So 200 times 0.5, right? What's 200 times 0.5? Okay, 200 times 0.5 is 100. Okay, so that's 100. Makes sense. Okay, what's the variance in standard deviation? Well, the variance of X is NPQ. This is how far away I am, okay, from the mean. The mean is 100. So on average, how far away? Okay, this is a measurement of how far away from the mean I would be. Okay, and so NPQ, okay, is going to be, this is 200 times 0.5. And if P is 0.5, then what's Q? Well, Q is 1 minus 0.5. Okay, and what's 1 minus 0.5? Well, 1 minus 0.5 is 0.5. So this is just 200 times 0.5 times 0.5. Okay, plug that in. 200 times 0.5 times 0.5. Okay, and that's 50. Okay, so this is equal to 50. That's the variance. Okay. I don't know why that did that, but that's okay. Let's go back. Okay. I don't know why it closed out for whatever reason. Okay. So 200 times 0.5 times 0.5 is 50. Okay, so what's the standard deviation? Well, that's just the square root of NPQ, which is really what I want. And that's going to be the square root of 50. Okay, which is approximately 7.07. So 7.07. So on average, the standard deviation is 7.07. So, you know, if we looked at the mean of 100, and then we were here at 7, you know, 7 less, which would be about 93. Okay, so 93, and then we'll be at 107. This is about 1 standard deviation above and 1 standard deviation below. Okay, so on average, we're about 7 units away from the mean. Okay, would you, outside of what range of values would you consider to be unusual? What would be 2 standard deviations below or above, right? Because usually we say like 95% are within 2 standard deviations. So outside of what range of values would be unusual, well, if I take this 7, it's approximately 7, if I subtract 2 of them, okay, 93 minus 7 is 86. And 107 plus 7 is 114. That's an easy one. Okay, so 95% of the data is going to be here. Okay, so 86 to 114. Okay, so so anything outside of this, okay, outside of this range, okay, outside of this would be an unusual value. Okay. Okay. Example 7, about 1% of the population has a particular genetic mutation. 600 people are are randomly selective. Find the expected number of people with the genetic mutation. Okay, well, E of X is just NP. Okay, 1% has it. I would consider that a success, unless, you know, maybe it's an advantageous gene or non-advantageous gene. It doesn't matter. We're just going to say that the 1% is the success, which means 99% is the failure, right? So P is equal to 0.01. So N is 600 people. 1% of that is going to be 6 people. Let's just verify that. 600 times 0.01 is 6. Yeah, so 6 people are expected to have the gene. Okay, so find the standard deviation. Well, again, the standard deviation is just the square root of NPQ. So that's the square root of N times P. Well, we already know what N times P is. We just got that in the previous, that's 6. 6 is N times P. What's Q? Well, if P is 0.01, then Q is 1 minus P, or 1 minus 0.01. So this is the square root of 6 times 0.99, which is equal to, okay, 6 times 0.99. Okay, and then take the square root of that, and I get 2.437. 2.437. Okay, that's my standard deviation. So where's the mean on this? The mean, the average would be 6, and then the standard deviation would be about 2.5. Okay, so about 2.5 up and about 2.5 down. So this is going to be 8.437, and then if I do 6 minus that, you know, and we could say that, oh yeah, you know, we have this nice little distribution here. It's discrete, it's not continuous. We could get these nice little, you know, this distribution here, and the average is at 6. Okay. However, our N is so incredibly large. N is 600 here, that we would go, you know, we'd start at 1 and then we would go up to 6, but then we would have to go all the way up to 600. So you get a lot of small values. Okay, the further you go up. Okay, but the bulk of your data is going to be right around 6. Okay, so as you know, to get 600 people with a 1% genetic mutation, that would be extremely small probability. So this is just it's gonna probably look like that and have a huge tail. So it's gonna be right-tailed. Okay, a huge right tail on the whole thing. This is getting kind of messy, so I'll just leave it like that. Okay. Okay, so that's the binomial distribution, and I will see you in the next video. Okay.